Hello, I'm Jason.
I'm John.
This is our extra credit video for calculus. Okay, so John, do you know anything about probability?
Yeah, I think I heard of that. It's like rolling dice or flipping coins, like that, right?
Well, that's discrete probability. Do you know anything about continuous probability?
Continuous probability. Is that like flipping a coin for the rest of my life? I don't want to do that.
Um, Not quite, John. So, continuous probability basically describe a distribution using a PDF, which is a probability density function. So, and then, if you wanna, let's say, if you wanna find the probability where x is smaller or equal to 10, then and x is distributed for all values, for all real numbers, then you just integrate the PDF of x from negative infinity to 10. So that's called the cumulative, the CDF of x, which is the cumulative density function of x. So that's just a description of how continuous probability works. And now let's see how the double integral we just learned have some application for the continuous probability when there's two variables. So now we have PDF of x which we can say it's f of x, small f of x, and the CDF of x is the integral of small f of x dx, which give a big f of x. Okay, what if we have two variables, x and y? Well, now it's interesting. So now we have the PDF of y, which is f of small y, and CDF of y, which is integral of f of y dy, give you big f of y. Let's say we want to know what happens if we want to have something like fx and small f y. So this is a joint PDF of x and y. So how do we find the CDF of x1? How do we find, if we want to know x, what's the probability x is smaller than and equal to 10, and y is also smaller than equal to 10? So we need to find big F of x and y. And actually, this is when we need to use double integral of small f of x y dx dy. So this way we find the joint for x and y, and now there's also a concept in probability says the marginal distribution of x and y, which says if we have small f x and y, and we want to know what if we don't care about y anymore, we just care about x, then the marginal distribution of x and y, let's say f big S bottom x and y, is just integrate big small f of x and y dy. This gives us the marginal, and then and the same on the y, we just integrate over x and y dx. So that gives the marginal for y. So as we can see, this is some application of double integrals in probability, and how that can help us to find the CDF of two variables, which is I think is very interesting, and which makes sense because we mainly learned about the geometric kind of application of double integral, but here we have something more algebra and more probability side of double integral. So hope you enjoyed the video.